Alright, so now I would like to introduce the reference angle. And the definition of a reference angle is the acute angle formed by the terminal side of theta and the x-axis. So that would be either the positive or the negative side. And so let's draw one of those here. I've got my axes. X-axis here, y-axis here, and let's do theta is equal to 160 degrees. So starting from the positive x-axis, if I rotate 160 degrees, it would go to about there, and that means our terminal side runs up here. So this is 160 degrees. Now the reference angle is the acute angle formed by the terminal side, which is right here, and the x-axis, either the positive or the negative side. Well, this is not an acute angle, but the other side is. So that means that this is the reference angle, and we call that alpha. And so we need to figure out, well, how much is alpha? And you can probably see by this diagram that it would be the rest of that angle until we get to 180 degrees. So alpha is equal to 180 degrees minus 160 degrees, which is equal to 20 degrees. So 20 degrees is the reference angle for 160 degrees. And one of the things you'll notice about that is if you start to do some trigonometric functions with an angle and its reference angle, that they are the same numerical value. Sometimes one is positive, one is negative, but they're the same numerical value. So you could practice that with your calculator. Sine of 160 and sine of 20. And so let's check that with the calculator. So that is 0.3420, and so is this, 0.3420. And notice they're also both positive. Now let's look at why they're both positive. All trigonometric functions are positive in quadrant 1, which is kind of where 20 degrees is, because it's a quadrant 1 angle. 160 degrees is in quadrant 2, where only sine is positive. So they should both be positive. If I did a different trig function of 160 and 20, like cosine or tan, then it will be positive for the quadrant 1 angle, but negative for the quadrant 2 angle, and that's what CAST rule tells us. So here's a practice for you. Looking at a different quadrant, find the reference angle if theta is equal to 195 degrees. So we would want to draw a diagram, 195 degrees, so starting here, actually, I'm going to let you do it. Pause the video and try to figure this one out. So starting from the positive x-axis, rotate around, we go past 180, and we're into quadrant 3, draw that terminal side. This is 195 degrees. 180 was right here. Where does alpha sit? Alpha is the acute angle formed by the terminal side and the x-axis, either the positive or the negative side. And so alpha is all of this in here. How do we figure out that amount, knowing that this side, the terminal side, is at 195 and the x-axis is the 180. So that means that alpha is equal to 195 degrees minus 180 degrees, which is equal to 15 degrees. Okay, one more for you to try. What is the reference angle for theta equal to 315 degrees? Draw the angle, determine where alpha sits, and see if you can figure out how much alpha is. Pause the video. Alright, so 315 sits about here, which means I have measured from here all the way around past 270 to stop here. And where is the reference angle? It's formed by the terminal side and the x-axis, the acute angle. So that's in here. Alpha. Alpha is equal to, how are we going to figure out that amount, what's left until we get to 360? Well, we'd have to do 360 minus 315 equals 45 degrees. In general, you can probably see we did 3 different things for quadrants 2, 3, and 4 to determine alpha. So finding alpha, let's write down some formulas. Finding alpha given theta. If it's quadrant 1, and you can tell it's quadrant 1 by the size of the angle, it's between 0 and 90. Then in that case, alpha is equal to theta. There won't be any change. If it's in quadrant 2, then alpha is equal to 180 minus theta. If it's in quadrant 3, alpha is equal to theta minus 180. And quadrant 4, alpha equals 360 minus theta. Notice we're always using the horizontal axis to measure or to find the difference, not from 270 or 90, okay? Always from the horizontal. So this leads us to one more thing that we can work out with solving equations. Now, in class we looked at how to solve an equation that we're looking for the angle when we are given the trigonometric ratio. And we discovered how to use the calculator to find the angle that makes this trigonometric ratio. And at the time we were only focused with the angles between 0 and 90. But now, if I told you that this theta lies between 360 and 0, so basically it's within one full circle. From the cast rule, which quadrants are we going to expect this angle to be in? We have a positive sine function. Where is sine positive in terms of the cast rule? Well, they're all positive here. They're all positive here. So we should be looking for angles in quadrants 1 and 2. If it's negative, we would be looking for angles in quadrants 3 and 4. But we're focused with angles in quadrants 1 and 2. So let's just go back to this question and do it the way we did last week in class. So solving for theta. Theta equals sine inverse of 0.5299. Get your calculator for practice. Find out what angle that is. Just round it to a whole number. And you will have one of 2 answers. So the calculator will give you one answer. You need to use the cast rule and the right equation to find the second one. Alright, so using the calculator, you punch that in, it says theta, and we'll take it to a whole number 32 degrees. Let's draw that. Roughly there, okay? 32 degrees. But we also know that sine is positive in quadrant 2. So there's also an angle that is 32 degrees from the x-axis over here. And these would be the same. So this is a 32 degrees. So this is theta, but it's also alpha, a reference angle. This is theta in quadrant 1, but it's also our alpha. What about theta in quadrant 2? How are we going to find that? Well, that means for quadrant 2, well, we just have to rearrange this equation. We know alpha over here, 32 degrees, and so we would say that, well, 32 degrees is our alpha is equal to 180 degrees minus theta. Rearrange this equation, and it becomes theta equals 180 minus 32, which is equal to 148. So 148 and 32 are the two angles theta that satisfy this equation. Alright, so again, let's try one more. Find two possible angles for theta between 0 and 360. Given cos theta equals 0.5736. So we know that we've got the cast rule. Let's use that cast rule right over here. Cast. And we have a positive value for cosine. Since it's not written as a negative, it's a positive. Where is cosine positive? That's what you have to ask yourself. So cosine is positive where they're all positive. It's also positive in quadrant 4. So that is where our angles will be. So let's sketch that drawing. Let's go like this. I'm going to have an angle here, and I will have an angle here. And these will be the same size. So it's a reflection. Now we need to find one of them. So that is done by solving this equation. Theta equals cos inverse 0.5736. Get your calculator. Find out what that angle is. Round it to a whole number for the sake of practice. And you'll find that theta equals 55 degrees. Alright, so this in here is 55 degrees. That means that this space in the other side is also 55 degrees. What is the positive angle that rotates from here all the way around and stops 55 degrees from 360? Theta in quadrant 4 is equal to 360 minus 55 degrees, which is 305 degrees. Thanks for watching.